Hi, our lesson now is about Spearman's rank and chi-square independence test. Let's start by talking about the Spearman's rank correlation coefficient. We refer to it as RS. The Spearman's rank is somehow like the Pearson's product moment correlation coefficient, but the only difference that for Spearman's rank, I take the rank of my data. How do I rank my data? The highest value, I always assigned the highest value to be 1, and descending and assign 2, 3, 4, and 5, etc. So now, why do we use Spearman's rank? We use Spearman's rank correlation coefficient when the rank of data is given and when there are outliers, because the Spearman's rank is not affected by outliers in data. When we have outliers in our data. Now let's solve a question from the IB question bank to show clearly how we'll be using Spearman's rank correlation coefficient. A Malvern Aquatic Center hosted a 3-meter springboard diving event. The judges Stan and Manson awarded 8 competitors a score out of 10. The raw data is collected in the following table. I have the competitors, I have Stan's score as the X variable and Manson's score as the Y variables. Here we have the original data, we have the scores. The commissioner for the event would like to find the Spearman's rank correlation coefficient. We need to copy and complete the information in the following table. So I have the competitors and I have Stan's rank and Manson's rank. Let's rank first Stan's score. The highest value always takes 1. Then the 7.1, because it's the second highest value, it takes 2. And then I have 3 6s. The 3 6s, this is the third, this is the fourth, and this is the fifth. But since we have 3 6s, the rank would be, I will take the average of 3 plus 4 plus 5. So it will be 3 plus 4 plus 5, all of it divided by 3. And this will give me 12 over 3, this will give me 4. So the rank for the 6s, they will all take a rank as 4. Now, after that, since it's 3, 4, 5, we give them all 4s. After the 5, we have the 4.3. So this is rank 6, and the 4.1 rank 7, and this is rank 8. So we fill in our data. This is the second rank. This is 4, 4, and this is the 6th, and A is the 7th. Let's rank the Y scores. The 9.5, which is the largest, gets a rank of 1. Then the 9 is the second, gets 2. Then I have 7.8, it gets 3. Then I have 7.2 twice. So this is the 4th and 5th. But I can't write 4 and 5 because both have the same value. So to find their rank, I will be adding 4 plus 5 divided by 2 to take the average, which is 4.5. So this rank would be 4.5 and this rank would be 4.5. After that, I'll be having the 4.8 as the 6th value. This is the 7th and this is the 8th. Now, This is the second. This is the third. This is 4.5, 6th, and 7th. Now we filled in the tables. Let's see part E, section I. Find the value of the Spearman's rank correlation coefficient RS. In order to find the value of RS, I need to use my graphical display calculator. I go to statistics. I fill in the lists with the ranks. Already, I filled them in before, so I have the list 1 having Stan's rank and list 2 having Manson's rank. After that, I go to calc, reg, x, and ax plus b. Exactly as finding the correlation coefficient, the Pearson's product moment correlation coefficient. So the value of R is 0.933. So the value of R is 0.933. Part E, double I, we need to comment on the value of R. This is positive. So we say that there is a strong positive correlation between the two scores. There is a strong positive correlation between X and Y. Now the commissioner believes Manson's score for competitor G is too high and so decreases the score from 9.5 to 9.1. So for part G, he decreases the score from 9.5 to 9.1. The question is, explain why the value of the Spearman's rank correlation coefficient does not change. The value does not change because 9.1 is still considered to be the largest value to be ranked as 1 because it is still considered to be the largest value. And by this, we could solve an IB question bank on Spearman's rank correlation coefficient. All of the question, they have the same criteria. So the understanding of how to solve such a question is very important. Now, let's talk about the chi-square test for independence. The chi-square test for independence is used to test two variables if they are independent of each other or not. We start the chi-square test for independence by setting our hypotheses. We start with the null hypothesis, which we write it as H node. Always with the run null hypothesis, we state that X is independent of Y. Also, we have the alternative hypothesis, HA, or we write it as H1. We say that in the alternative hypothesis, X is not independent of Y. This is the first thing that we have to know about the chi-square test. The second thing, we need to know how to calculate the degrees of freedom. Degrees of freedom, which we write them as D of F. These are equal to the number of rows minus 1 times columns minus 1. Also, we have to know how to find the expected value for any measure in the observed frequency table. So the expected value is always equal to the row total times column total, all of it divided by the grand total. In our test, we need to find the chi-squared calculated, or we can refer to it as the chi-squared statistic. Also, we need to find the p-value. And after that, after finding the chi-squared calculated and the p-value, we need to compare them. First, we need to compare the chi-squared calculated with the chi-squared critical value, which is always given in the question. If the chi-squared calculated is greater than the chi-squared critical, then we reject each node. If the chi-squared calculated is less than the chi-squared crit, then we don't reject each node. For the p-value, we have to compare the p-value found with the significance level. So now, if the p-value is greater than the significance level, let's start having it lower than, because it's the opposite from the chi. So if it's lower than the significance level, then we reject each node. If the p-value is greater than the significance level, then we don't reject each node. I hope it's clear. Now, let's solve an example from the IB question bank. A hospital collected data from 1,000 patients in 4 hospital wards to review the quality of its healthcare. The data showing the number of patients who became infected during their stay in the hospital was recorded in the following table. We have this table. The first thing I need to know the table, I have to describe the table. We always describe the table by multiplying rows times columns. In our case, this table have 2 rows because I always exclude the rows for the total times 4 columns. So rows times columns is always written as m times n, which in our case I have 2 times 4. Now, a chi-square test was performed at the 5% significance level. This is the significance level. And the critical value, as you can see, is given in the question, 7.815. The null hypothesis, always the null hypothesis, we say that the two variables are independent. So becoming infected during a stay in the hospital is independent of the word. Part A, find the expected frequency of the patients who become infected whilst in Nightingale ward. So the patients that are infected whilst in Nightingale, this is the value. So in order to find the expected value, I need to multiply the total of the row times the total of the column divided by the grand total, which is 1000. So for part A, the expected value is equal to 100 times 330 over 1000, and this will give me, I go to simply the run matrix. I have 100 times 330 divided by 1000. It's equal to 33. So this value is 33. For this test, for part B, we need to write down the chi-squared statistic. So now, for part B, the chi-squared calculated, I need to use my graphical display calculator. So I go to menu, statistics. I go to test and then chi, and I choose 2A. I go just to matrices just to delete all, and I get back. Now, if you can see that the observed frequency is in matrix A and the expected frequency is in matrix B. To edit these matrices, I need to press the arrow and mat, which is F2. I go to F2 and I have to edit matrix A. So I choose the dimensions. My matrix is 2 times 4. And I press enter. And now I need to fill in the values. I have 44, then 27, then 13, 16, 281, 303, then 182, and 134. Now exit again, exit, and now I execute to find the value of chi-squared statistic. So this window gives me the chi-squared calculated or chi-squared statistics and the p-value. In our case, we need the chi-squared statistic. So this is 8.21. So now the chi-squared calculated is 8.21. Let's see part C. State giving a reason whether the null hypothesis should be rejected. I have the chi-squared calculated and the critical value. For part C, the chi-squared calculated is simply greater than the critical value, which is 7.815. And because of this, since the chi-squared calculated is greater than the chi-squared critical value, we need to reject H node, which means we accept the alternative hypothesis, which means that becoming infected during a stay in the hospital is dependent of the ward, or we can say it as is not independent of the ward.